Okay, so now we're going to talk about some more basic trig identities. Now, some of these you've already seen, specifically these. So we know that like secant is 1 over cosine, cosecant is 1 over sine, tangent, sine over cosine, cotangent is the reciprocal, so therefore it's the same as 1 over tangent, and cosine over sine. So pretty straightforward ones, but these are the ones you should have committed to memory. We also talked a little bit about odd and even functions. Key thing, cosine and anything related is going to be, so just cosine and secant are going to be even. So cosine opposite x is the same as cosine x. Whereas sine and anything that involves sine, up to and including tangent and cotangent, right? And I actually should say cosecant and secant. So let me fix this actually. It means that cosecant is equal to the opposite cosecant. There we go. That makes a little bit more sense, otherwise it doesn't make sense. But those are the different identities, and once again, things you should commit to memory. So I'd start working on that, though there are patterns that make it not too terrible. Okay, there are a couple others. The Pythagorean identity. Remember, in general, if I have some sort of angle, right, in the unit circle, right, so I know this is 1, 0, and 0, 1, and all that good stuff, right? I know that the length of the hypotenuse of any right triangle that I draw is equal to 1. And I also know that the side lengths of this, right, this side length, that is, remember these points, this point here corresponds to the cosine of the angle and the sine of the angle. Which means in reality what I've got is a right triangle where the hypotenuse is 1, the x, the side length of the x is cosine theta, and the side length of the y is sine theta, which means that sine squared theta plus cosine squared theta is equal to 1, or 1 squared. That is the basic Pythagorean identity. So you can see why it's called a Pythagorean identity. Works for all angles. Now, there are two derived ones. What if I take this and I divide everything by sine? Take this whole mess and I divide it by sine squared theta. Well, I get a different identity that's related, but it's another Pythagorean identity. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared. Cosine over sine is cotangent, so that means that this is cotangent squared. And 1 divided by sine squared, well, 1 over sine is cosecant, so this is cosecant squared theta. So this is the second Pythagorean identity. I would argue that if you know this first one, which I would commit to memory, you can get this one just by dividing everything by sine squared. A little less to memorize. And similarly, if I were to take sine squared plus cosine squared equals 1 and divide it by cosine squared, I would get another identity, specifically, well, sine over cosine is tangent, so this is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is our friend secant squared. So these three things here are what are called the Pythagorean identities. Commit this one to memory and understand how to derive these two. Other two would be my advice. Okay? Now, identities from right triangles. Now these only work for acute angles, by the way, because what we're going to use is a right triangle here. So if I'm looking at this, and let's say this angle is theta, being a right triangle, that means there's how much left for this? And the answer is 90 minus theta. If you think about it, these two angles have to add to 90. So if this one's theta, this would be 90 minus theta. What does this get us? We know that the sine of theta is equal to the opposite of the hypotenuse, right? So we know it's the, let's go with this x, r, and y, right? We know that it's equal to x over r, right? Now, if we look here, and we'll change our focus, so we're looking at 90 minus theta. So what trig ratio would involve x and r? Well, where in this case, this is the opposite, and this is the hypotenuse. So I'm looking at this. This becomes the adjacent in the hypotenuse, which is the cosine. So what this means is sine theta equals cosine 90 minus theta. So it also means, if I switch this around, if I take the cosine of theta, which would be y over r, and I switch over to 90 minus theta, that's, I switch over to this angle, now the y is the opposite, so it's equal to the sine. So it works both ways. That is, you can think of sine and cosine as being paired. If you continue this process, like if you look at tangent theta, which would be x over y, right?
I didn't think you left.
What happens if you look at the other angle? X is the opposite for this, but x changes to the adjacent. That is, the opposite and the adjacent switch. So this is the same as the cotangent.
Yeah, I double checked. I figured.
All the trig ratios get paired off this way. When you look at this, that is, and these are sometimes called the complementary identities, because 90 minus theta would be the complement of theta, such that we get this. So sine matches with cosine and vice versa. Tangent matches with cotangent and vice versa. Secant, which is related to cosine, matches to cosecant. See? So it's not too terrible to remember. Sometimes you'll see this written with a pi over 2. In other words, pi over 2 minus theta or minus x, rather than 90 degrees, but it's still the same thing.
So in about literally
And that
4 minutes, I'm going to
are some basic identities that you're going to want to make sure you understand.